we're always having the time in the x-axis, and we have the displacement in the y-axis, and we know that displacement divided by time will give us what? Will give us the velocity, which is the change in y divided by the change in x, the gradient. So it will give us the velocity right there. So the answer would be C. Okay. In question 7, he's saying a luxurious speedboat traveled down the French river with an initial velocity of 10. So we have here the initial velocity equals to 10, which is very important to get out the givens first while you are reading to make it easier to solve the question. So here we are gonna go over the kinematics equations, or the S U V A T. Height, delta x or delta y, depending on the question that you are solving. Initial velocity, final velocity, acceleration, time. Okay, so let's see. Here we have the initial velocity, which is u right there, equals to 10 meters per second. Okay, the owner wishes to show off the power of the engine, so accelerating at a rate of 2 meter per second squared. So here we know that the acceleration would be 2 meter per second squared. For 5 seconds, of course, this would be the time. So we know that the time would be 5 seconds. And this all the given that we got from the question. So we don't have what he's asking for. It's asking for the final velocity of her speedboat. So I'm asking about V. Okay. So here the only thing that I don't have in the question is S. So we don't have delta X or delta Y in the question. And we need to solve this. So these equations, you need to memorize it always, because there will be a question on the exam regarding this. So first one is saying the final velocity equals to initial velocity plus acceleration multiplied by time. This is the first one. What about the second one? It's saying the final velocity squared equals to the initial velocity squared plus 2a, depending on delta x or delta y. So I'm going to write s at the x or y, depends on the axis that we are solving in. And the third one is s, which is delta x or delta y, depending on the question, equals to u multiplied by t, which is time, plus half a t, which is time also, squared. Last one, which is, let's write this. Yeah, we can do this. We write this. Okay, that's okay. And also we can write another one, which is same, but we are going to change it. Instead of plus, we are going to do it minus. So this is in x-axis, but in y-axis, probably it would going to be minus. And we have the last one, it would be displacement equals to half plus by v plus u plus by t. And that's it. This is all for the kinematics equations that we are gonna use regarding this course. Okay, so you should memorize it and write it down as notes. We are gonna search right now for a best one to use to solve this question. So I think that we should use an easy one, since we only need to find the final velocity. So what about the first one? We are searching for the final. We have the initial one. Yeah, we have it. We have the acceleration. Yes, we have it. We have the time. Yes, we have it. So probably the first one would gonna be a great deal with solving this one. So I'm gonna delete the rest. Okay, I'm gonna delete all. I'm gonna use that first one, which is saying that v, final velocity, equals to initial velocity plus acceleration multiplied by time. So we know that the initial velocity is 10 plus acceleration is 2 multiplied time, which is 5. 2 multiplied 5 is 10. 10 plus 10 is 20. So the answer would be 20. And we are searching for final velocity. So probably it's meter per second or meter second to the power of -1. So the answer would be A. So getting out the givens first, and after that, see which equation we're gonna best fit the given that I got from the question. I was searching for this one, okay? This one is not important in this question. Okay, let's go for the next one. Okay, in question 8, he's saying the graph shows the motion of a sky diver in a free fall. As you can see, velocity versus time. What point on the graph represent the skydiver reaching the terminal velocity? Okay, reaching the terminal velocity means what? Means he reached when the upward force acting on the skydiver will gonna be equals to the downward force of the weight. They are equal to each other. So once they are equal to each other, we reach the terminal velocity. Okay, So when they're gonna be the downward force, which is the weight equals to the force acting upward on the skydiver, when they're gonna be equal to each other, there will not gonna be any acceleration right there. So acceleration will be equal to zero. Let's go regarding the equation of the acceleration or the formula of it. Acceleration equals to change in velocity divided by change in time. 100% I will not get in any time that change in time is equal to zero, because time is always moving forward. Probably here we're gonna have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever the number. So once you do the final minus the initial, you will get a number at the time. So I cannot get acceleration equal to zero from time. So what about the velocity? Yeah, I can get, when I do the difference between the final velocity minus the initial velocity, if they are the same, I can get the acceleration equal to zero. So the change in velocity, I think in D, A is not, here we are having the velocity accelerating right there. So A is accelerating. In the B situation, it's also accelerating. In C, it's accelerating. In D, you can see a straight line right there. So the difference between the final velocity and the initial velocity, let's say that here we have the velocity as 10. So here's 10 and here's also 10 in the 2 points. So when you make 10 minus 10, the final minus the initial, you will get 0. 0 divide any number, you will get a 0 answer. So once you get the 0 answer, you will know that we reached the terminal velocity, that there is no acceleration on this situation. The downward force is equal to the upward force. So in this situation, the answer would be D. In question 9, he is saying a ball thrown upward with an initial velocity of 3 meters per second. Which SUVAT equation will correctly calculate the maximum height reached by the ball? There is a way to solve this one without even reading the answers. Once I wrote before the equations of the kinematics one, or the SUVAT, uh, you will find that there is always a one equation without time on it, which is this one. And the question, there is no any given regarding time. So once you find this in the question, go directly to the one that is not having a time on it. Why? Because it is asking about the maximum height. So I'm asking about S. Okay? Okay. In the first one, there is no anything regarding the S, so it's not the right one. In this one, okay, we have S equals to initial velocity multiplied by time. Okay, what is time? I don't know. I cannot have two unknowns on one equation and find a final answer. Not making sense. Also in this one, we have S, the one that I'm searching for, and I have time. Also, I don't have the time. So here we have two unknowns. So this one directly going to be eliminated since there is no S right there. I'm searching for the maximum height. And this one will be eliminated since I have two unknowns. And this one will be eliminated since I have two unknowns. I'm going to go directly for C because I have only one unknown right there, which is S, and I don't have time. And whatever the rest, I have it. The final velocity, the initial velocity, all of them, I have them. So I can get the answer from using this equation. You're going to ask yourself, he's saying I have the initial velocity, which is 3. What is the final velocity? I don't have it in the question. No, you have it. Why? Because he is saying calculate the maximum height. If I throw up the ball, when it reaches the maximum height, the V final in this situation, because here I'm asking about the maximum height. So at the maximum height, velocity is equals to 0. In the maximum height, the velocity is equals to 0. So yeah, I have the final velocity, which is 0. I have the initial velocity, give it to me, 3. I have 2. I have the acceleration right there. So what is going to be the acceleration? You're going to ask yourself, oh, I don't have the acceleration in the question. Okay, the acceleration is regarding the gravity because I throw the ball up. So what is acting right there on it? The gravity. So I can use it as the acceleration equals to negative 9.8. So all what I need, I have the final velocity, which is 0. I have the acceleration, which is negative 9.8. I have the initial one, which is equals to 3. Everything I have, I'm only asking about the maximum height, which is S. So directly, I'm going to use this one to solve the question. But to make it easier in the exam to save time, once you find an equation without time and you don't have that given in the question, so probably you're not going to solve with two unknowns. You're going to go directly with the third one, which is C. Okay, last one is saying draw a graph that the acceleration time 1. Okay, we have an acceleration, we have time. What can she deduce from this graph only, and what quantity from the graph is used to make this deduction? Easy. acceleration time. So acceleration is equals to change in velocity divided by change in time. Okay, so once you have acceleration and time, what you'll get, what is the missing part? Velocity. So probably it's not changing the position, so it's not C, it's not C. Between A and B, is it a change in velocity for the A1, which is gradient of the graph, or area under the line? So probably I'm gonna go for the area under the line right there, would give me the change in the velocity. And this would be answer B.